Good evening, everyone. Welcome to the Apache Iceberg, and I am Rayner Chen, the Apache Doris PMC chair, and also the vice president of technology at the VeloDB, which is a company provide a commercial product powered by the Apache Doris. So today I like to talk about how to build a fast data lake analytic on top of the Apache Iceberg and Stories. So first I want to show you about what the Apache Doris is. I think many of you have not heard of it or used the Doris. And next I will talk about how to build the lakehouse solutions based on the Apache Iceberg and the Doris. And finally, I will give a brief showcase about the Doris and the Iceberg. So I hope you can learn something today, and the learning team might be able to implement your own lakehouse solution. Okay, the first is what is Apache Doris? This is a diagram from the Apache official website. Doris is a modern data warehouse offering the lightning fast analysis on the large scale real-time data. So you can see where Doris fits in a big data platform. The upstream system, including the database, the data stream, and the data lake, and other structured and semi-structured data. And Doris can access this data using two ways. One way is to import the data into Doris by using some pipeline tools or batch or streaming data processing. And the other way is to query this data directly through the Doris connector framework, especially for the data lake acceleration. And finally, Doris can offer provide the query service to the end user directly, the reporting and ad hoc query and the data lake analytics and some ETL or ELT data processing. So Doris is one of the most active open source community in the big data area. So we have a total about 650 total contributors and 100 monthly active contributors. So it is a very vibrant and a rapidly evolving open source project. So, and it's also trusted by over 5,000 enterprises worldwide for the online analytics, like the industrial, like the retail, the finance, the internet, gaming, and telecommunications. Okay, here's a quick look at the Doris architecture. And Doris has two main processes. One is front end, or FE for short, and one is the back end, or BE for short. The FE is responsible for the cluster management and the metadata management and the query planning, and it is written in Java. And BE is responsible for the data computation and the storage, and it is written in C++. So from the version 3 of the Doris, we have two architectures: the compute storage coupled and decoupled. For the coupled storage, you can see that is the typically MPP architecture, and the data is stored on the local BE knows the local disk, and it's very simplistic. And for the compute storage decoupled architecture, we introduced a shared storage like the cloud object storage, like S3 or the HDFS, and a unified meta service. So it can make the FE node and BE node stateless for more elasticity. So user can choose between these two architectures for the simplicity or the elasticity. Okay, now let's talk about the main feature of the Apache Doris. There are three main features. The first is lightning fast. I think it's one of the world's fastest data query engine. I will show some benchmark later. And the next is easy to use. Doris is very friendly for the first-time user with low operational cost as a distributed system. And it provides the flexible deployment options for various environments. And the last is multi-scenario support. Besides the typical reporting and ad hoc queries, it also supports the semi-structured data analysis like the log management, and also the most important as a lakehouse query engine. So moving on to the query performance, here are some benchmarks to show. The first is the ClickBench, which is released by the ClickHouse company. And it reflects the query performance on a single wide table with about 100 columns. And you can see Doris is the fastest query engine, only slower than the in-memory database like Canberra and some tuned or optimized ClickHouse. The next is the TipCDX. We compare this benchmark to the another famous MPV database, the Greenplum. unfortunately, the print farm is not open source this year, and you can see the Doris is outperform about 5 to 10 times faster than the print farm. And the last is the TPCDS benchmark. In this benchmark, we compare to another famous per engine Trino. And in this benchmark, the data is stored on Hive. And both Trino and Doris will query the data on Hive. You can see that in this benchmark, Doris is about 3 to 5 times faster than the Trino. So you can see both for the single table query or the complex and multi-table join query, Doris can also give a better performance. So Doris excellent performance based on the many technology like the cost-based optimizer, the columnar storage, the materialized view, the smart caching, and the vectorized query engine, etc. And I won't dive into this technology today because we are short on time. But what I would like to highlight is Doris the fast performance based on tons of engineering work behind the scenes. So next is easy to use. The first, Doris have a built-in MySQL protocol layer, so you can use any standard MySQL tools to connect to Doris or the library of any program language to connect to Doris. And it's also a relational database. So you can use the standard SQL like create database, create table, the Slack insert into the standard the SQL to do operation in Doris. So it is very friendly for the first-time user. You don't need to learn some new conception about database and can use Doris just like MySQL. So and next, it can be deployed everywhere. About the bare metal, the EC2, the Kubernetes, or use the commercial product like operating your own cloud or SaaS. So from the user aspect, I think the Doris is very easy to get started. And as a distributed system, we also face some like a node failure, the disk broken or network error, and Doris can handle this automatically, like to repair the replica automatically if when the disk is broken, or do some auto rebalance when we do the scaling up and down. The Doris also support the adaptive concurrency control and the fault tolerance, so you don't need to worry about the high cost of operating a distributed system. And Doris also support the resource isolation. So the purpose of Doris is the purpose of resource isolation is to help user to run different tasks within the within one a single cluster. So by using the resource group, the workload group, and you can do the resource allocation within or between the nodes. And we also provide the query fields feature. This feature can prevent some unreasonable query. For example, if a user send a SQL query to the cluster, which may cause too much CPU or I/O bandwidth, and Doris will automatically detect the situation and cancel the query if the predefined threshold exceeded, and it can help to improve the cluster stability. So lastly is the multi-scenario. The purpose of Doris is aimed to meet many is to solve the multiple needs within one product. And the first is the typical OLAP scenario, the reporting and the ad hoc query. The reporting query is refers to a reporting task which the query pattern is relatively constant. So we can optimize this situation by using some pre-aggregation data model or the smart data caching. So like I showed on this slide, for example, we have a base table with 3 columns: the name, the department, and the salary. And we can create a we call a roll-up table based on the base table. With one dimension column like the per department, and one metric column and a summary of the salary. And Doris will automatically aggregate the data and materialize it into the raw table. So if user want to execute a query like select department, some salary from this table group by department, the Doris will retrieve the data directly from the raw table to avoid some runtime computation. and to get the query more faster. And the other is the ad hoc query. Let me show. The ad hoc query also involve a large volume of data, and the query pattern is sparse. So Doris can also leverage its MPP, the massive parallel processing and adaptive pipeline execution query engine to give a very high throughput query service. So the other two scenario is the high concurrence important query and semi-structured data analysis. The high concurrent important query is refers to that a small amount of data need to be retrieved processively from a massive data set, like select star from billing, where user ID equals 123, and Doris optimized this scenario by some techniques like the row storage, the prepare statement, the source circuit query plan, and thanks to this optimization, Doris can offer tens of thousands QPS within single node. And the next is the semi-structured data analysis. The semi-structured data analysis typical like the log measurement. So user may import a large amount of log into the Doris to store and analyze. And Doris support the inverted index, the full text search index, and some flexible semi-structured data type like JSON and variant. And compared to the index search, Doris outperformed on the write performance, the write performance, the query performance, and has a very low storage cost. Okay, comes to the most important part of this today's presentation is to bring the data lake to Doris. So this is the catalog overview. A catalog is the important conception in Doris. It helps Doris to connect to other data sources like the Hive, the Iceberg, the Delta Lake, and query this data directly. So this is the diagram to show the data flow or the execution flow about how Doris access to the external data source. We fetch the metadata from the Hive store and to access data stored on the remote storage and some query acceleration technique like the remote data cache, the internal table, materialized view. So back to the Iceberg. This is a brief architecture about how to integrate Doris and Iceberg. The first is Iceberg is an excellent open table format. It provides the data insertion, update, deletion, and the schema and the partition evolutions and the time travel, etc. And I think Iceberg can be the one of the best storage format and can be act as a single source of truth for the storage. And on top of the Iceberg, Doris can be act as a SQL query engine. So you can see we split the Doris into three layers: the speed up layers, the process layer, and the access layer. In the speed up layer, first let's talk about the speed up layer. The data stored on Iceberg are usually stored on the remote storage, which means that we need to access the data through the network, which is maybe very slow sometimes. So Doris can to catch the frequently accessed data onto the Doris local disk to speed up the data access. And also, the Doris support the native Iceberg table format readers like the pure Parquet or ORC file format readers, the Iceberg V1 and V2 format, the position delete, the equality delete, all is written in C++ for the better performance. Okay, the next layer is the process layer. So you can see that Doris support the materialized view. So you can create a materialized field based on the Iceberg table or even based on another materialized view. So in Doris there are two main usage of the materialized view. One is you can cook the data. You can cook your data by creating a materialized view based on the iceberg table or based on another materialized view. And the Doris support the automatically data refreshing. For example, if you create a new iceberg, a new iceberg partition, a new partition in the iceberg table, the Doris will automatically refresh the related materialized view and incrementally at the partition level. So you can see we can use the material view to create a kind of a data pipeline in Doris, and each material view have different data stream for different user to query. And the other usage is to do the query acceleration, which means that the DBA can create a set of material view based on the user's historical query. And once the material view is ready, the query planner will try best to find the most suitable material view to fetch the data from it. That is what we said the transparent query writing. So user do not need to change its query to match the different material view. And one more thing, we're working on to support more catalogs like the Databricks, the Unity catalog, the Apache Gravitino, and the Snowflake Polaris to help users to manage the data in a more unified way. Okay, I will give a quick showcase about how to integrate Doris and Iceberg. And we can use the Docker compose to start the Doris and Iceberg cluster, and all the scripts I showed later can be found in this link from our official website. So first we can all these are done in Doris. So first we can create a catalog, Iceberg catalog, and you can see we connect to Iceberg REST catalog, and the Iceberg data stored on the MinIO object storage. And then we can switch to that catalog to create the database, to create an Iceberg table, and to specify the partition spec and the compression codec or the file format like Parquet. And then we can use the standard SQL like insert into to insert data to the Iceberg table, or you can just create a Iceberg table and select from another Iceberg table. It's all done in Doris and very simple. And then we can query data using standard SQL. So it's it's pretty simple and very natural. So Doris can also do the time travel of the Iceberg table. First, we can insert another batch of data into the Iceberg, and then we can query the Iceberg meta, the snapshot, and you can see there are two snapshots of the Iceberg table, and we can choose one of the snapshots to query to use the grammar like for version as of or for time as of, to fetch a different snapshot. And we will continue enhancing the capability of Iceberg in Doris, like the enhanced materialized view support to make it more like the incremental refresh, and the variety of catalog like the Unity catalog and the Apache Gravitino, and also we will provide the Iceberg data compaction service to handle some small files issues and the Git-like operation on the Iceberg table. Okay, that is my presentation today, and we are warmly welcome everyone to join the Doris community. Here are some ways to connect us, and thank you all.